Hi everyone, I'm Jack. Today I'm presenting our work, Verifiable by Design, aligning language models to quote from pre-training data. Large language models today are super powerful. For example, you can ask Copilot about news, and it will give you a list of detailed news headlines. However, they're not always reliable. In fact, they are known to produce seemingly plausible but erroneous outputs, which are usually called hallucinations. In this case, the user might wonder whether the fourth point here about Europe's economic laggers is actually a hallucination. To trust LLMs, users need to verify the generated claims against trusted sources. However, even if you have sources that are cited, for example, the New York Times front page in this case, it is still non-trivial to fact-check lengthy free-form generation. Existing methods for verifiability employ search and retrieval, and then post hoc produce citations. They help, but they do not guarantee to be accurate. In fact, it is non-trivial to also verify whether the generated text is supported by the citation, and citations themselves can be wrong. Instead, we propose increasing verifiability by generating verbatim quotes from high-quality sources of pre-training data, for example, Wikipedia. We propose quote tuning, which aligns language models to quote from their pre-training data directly. To do this, we make the model prefer generation with more quotes over less quotes. We align for quoting using preference optimization algorithms such as DPO. So we first have a base language model, and then we align them to quotes. Afterwards, the model generates statements with quotes, which are then post-hoc verified through verbatim matching from high-quality subsets of the pre-training corpus. As a background, we measure quoting at scale using QUIP score. Specifically, if we have a generated text Y and we have a large corpus Wikipedia, we calculate QUIP score as the percentage of n-grams that is found in C among all the n-grams found in the generation Y. Our QUIP score construction is backed by efficient membership testing with data portraits, which is a Bloom filter data sketch on a large corpus. Reinforcement learning from human feedback has been useful to align models to not only follow instruction and increase their helpfulness, and also reduce harmful outputs. We also use the preference optimization, but specifically, we use direct preference optimization, which simplifies the RLHF pipeline and optimizing a data set of preference without reinforcement learning. Specifically, DPL requires a preference dataset which consists of pairs of Y-win and Y-lose, where Y-win is the winning response and Y-lose is the losing response. This is then used in the DPL equation to compute a loss directly, which we can optimize using regular fine-tuning. Our method quote tuning is then a data curation algorithm that curates a preference data for quoting and then conduct preference optimization to produce the quote tuned LLM. We now introduce each step in detail. First, we sample candidate responses from a prompt dataset. In fact, we generate multiple completions from an LLM. For example, we use QA pairs or text completion datasets. We then construct a preference dataset by ranking generations by the amount of quoting using QUIP score. Here we have a chosen response which has high QUIP score and a rejected response which have low QUIP score, and they both have similar lengths with each other. Finally, we make the model prefer more quoting by assigning the chosen response as more preferred over the rejected response during the DPO process. After conducting preference optimization, we'll obtain a quote-tuned LLM. We find that quote tuning significantly increases the amount of quoting. Before quote tuning, Llama 2 7 billion chats only has sparse quotes that are not helpful for verifiability. After quote tuning, we now have densely quoted generation that are much easier to verify their correctness. We can obtain models with same quality but more quoting. In the baseline, we compute the equip score and Rouge-L score for Llama 2 7 billion chats. And we use according to prompting as another baseline. So they slightly increase quoting. We also have a strong baseline, which is best of 32 re-ranking. Basically, we generate 32 responses and then choose the response that have the highest equip score as the final response. In contrast, our proposed method, quote tuning, significantly improves quoting and even outperforms the baseline, which the best of 32 re-ranking baseline, which is 32 times more costly. On the other hand, we also find quote tuning to be very helpful to improve model truthfulness. On the truthful QA datasets, we also see a meaningful improvements of truthfulness from 54 to 61. On the other hand, we have slightly decreased informativeness number, which indicates that the model is now a bit more conservative in answering responses that they're not sure of. And finally, when we see the combined measure of truthfulness plus informative together, we also see a meaningful increase in the aggregated metric. We also conduct downstream evaluation for models before and after quote tuning. So quote tuning significantly improved quoting with only a minor sacrifice on the general performance. Across challenging benchmarks such as HelloSwag, MMLU, BBH, and GSM8K, we have minimal loss of performance, less than 2 points. Finally, quote tuning is also effective across different model families. We applied our recipe to Llama 3.1 8 billion instruct model, Llama 2 9 billion instruct tune model, and also starting 7 billion beta. And on all of these models, we show a significant improvements for quoting. To summarize our work, we find that large language models can be aligned to quote from known sources observed in their pre-training data. And in fact, quoting makes the verifiability question trivial. So we believe this is a very helpful way going forward to increase the verifiability of large language models. We leave open questions for future explorations. For example, how do we incentivize quoting when it matters in various different contexts? Also, how do we ensure long, contiguous quotes rather than certain shorter, segmented quotes as we have now? Moreover, an interesting direction is how to generalize quoting to reasoning problems and more general settings compared to the QA setting we have now. That's it for our talk, and thank you so much for listening.